Next, we are going to construct spin operators. So we already discussed how we can construct angular momentum operator. So angular momentum operator, remember, is given by R cross P. But how do we construct spin operators? So how do we construct spin operators? So let's do this using an example, a specific example. Let's take the example where L is half. So we're looking at a spin half system. So in that case, how many states do I have? Well, 2L plus 1 is just 2. So I will have 2 states. So these states are psi half, comma half, and psi half, comma minus half. So let's just write this as psi up, and let's write this as psi down. So because we have only 2 degrees of freedom related to the spin half system, that means that the wave function of the spin half particle will be a matrix wave function, which will be just a column matrix. So the wave function will be just psi up and psi minus. So it'll be a matrix wave function. So if it's a matrix wave function, the spin operators should be 4x4, 2x2 matrices. If it's a matrix wave function, the spin operators should be 2x2 matrices. So let's see. So we get psi x. The psi x operator, its ij component will be then given by the inner product of psi I acting on and psi x acting on psi j. And similarly, the matrix elements of sy operator will be given by psi I, psi y acting on psi j, and similarly psi z ij will be given by this expression. So it's easy to derive these. So let's just first let's derive sz. So we know that sz acting on psi up is going to be half times psi up. This is by definition. Sz acting on psi down is going to be minus half of psi down. So then we're going to, let's look at S up up. S up up is going to be psi up, Sz psi up. But Sz acting on psi up is half times the inner product of psi up with psi up is 1. So similarly, S down down is going to be psi down, Sz acting on psi down, and that's going to give me minus half. And then if I calculate psi up, psi S up down, I'll get psi up, Sz psi down, and this is going to give me half times inner product of psi up and psi down, but orthogonality tells me that this is going to be 0. Similarly, psi S of down up is going to be 0. So the Sz operator is going to be given by half 0, 0, minus half 0. So this is the Sz operator. So similarly, using the fact that S plus minus is Sx plus minus I of Sy, you can show that the Sx operator is half times 0, 1, 1, 0, and the Sy operator is half times 0 minus I, I0.